Hi guys, welcome back to the second video in our series on securing SQL Server databases. My name is Jayanth. I will be instructing you today on how to use principle of least privileges when securing a database environment. In this video, we're going to be talking about the principle of least privileges. And what that means for us is, as its name suggests, granting the bare minimum permissions required for an account to do its job. Now, an account in this case is basically nothing but a login followed by a user, and the permissions are granted to the user, which in turn allows the login to execute certain commands or perform certain tasks. Now, to understand this, what I'm going to do is, it's easier to explain it through a demonstration, so that's what we're going to do. First, I'm going to go ahead and switch to the master database. And once I'm in the master database, what I'm going to do is I'm going to go ahead and create a new database, a dummy database on which we're going to do our work. So that's going to be the database called DB Security. And once that DB Security database is created, we're going to switch to that database. And in that database, I'm creating a table called Secure Table, inside which I've got some columns like username, password, email, etc. Typically columns that you would think need to be secured in some form or fashion. Now I'm going to insert one dummy record into the table, and that's basically the record that we're going to try and protect today. In order to access SQL Server databases, you need to have a login. So what we're going to do is we're going to create a login with the username called dbuser and a password blah blah blah. Obviously your password needs to be much stronger than this. I have another video in the playlist where I've demonstrated what happens to an account which is using a weak password. So definitely something you want to worry about. Now inside a database, we have security being implemented in two layers. The first one is at the server layer, which is basically what we have here as a login. If I refresh this folder, you'll see that the login that I've just created, that I've not yet created, so let me just go ahead and do that right now, will be reflecting here. However, once that login is created, it doesn't really have permissions to do anything. For example, I could try right now to log in using this account, and I wouldn't really be able to do anything as far as accessing database objects is concerned. So let me just go ahead and try logging in. Guess I typed in the wrong password, so let me just quickly copy this. And there we go. So once I log in, you can see that I'm able to access the server, but inside the server I have a database, but I'm not able to get into the database to see what tables or procedures it has. In order to be able to access the database, what I'll need to do is I need to actually create a user corresponding to that login. So you'll see I'm going to create a user called dbuser, which is using the login called dbuser as well. And what happens is when you create an application, the application uses the login in order to connect to the database, and then in order to connect to the server. And then once connected to the server, it looks for a user or some kind of mapping to a user that already exists in any of the existing databases. And that's how it knows that it needs to traverse from the server into the database boundary. So I'm going to go ahead and create a DB user right now over here. And now that the user is created, if I refresh this guy, you will see that I don't get the error message pop up that we had the last time around, because now inside my database called DB Security, inside the security folder specifically for this database, I have a user. However, this user, as you can see, doesn't really have any other permissions to access tables, etc. So as you can see, what I'm doing is I'm incrementally granting permissions from the login to the user and now next to the table. And this is what the principle of least privileges is about. It's about granting permissions step by step so that you can make sure that the account that you're using to connect to SQL Server always has only the bare minimum permissions it needs to do its job. Having said that, there are ways around that which I will show you, and that's usually a result of bad coding practices or not understanding how the technology works per se. Not really a flaw, but just things that you need to watch out for. So as you can see, I've gone ahead and logged in as a DB user. The next thing I'm going to do is I'm going to go ahead and grant the permission to the secure table, but only to the column called username. So you'll see that here we've got a number of columns. We've got ID, username, password, email, social security number, credit card number. And what I'm doing is I'm not going to go ahead and encrypt the details inside these tables, mainly because encryption has a significant CPU overhead, which I've already mentioned in the previous video. So in a situation where I think that maybe encryption is overkill for what I'm trying to do, I usually just try to restrict permissions by making sure that it doesn't have the select permission on the column unless it's elevated by using some kind of application user. So as you can see here, what I'm going to do is I'm going to grant select permission only on the column that I'm interested in. And once I do that, if you look over here, what I'm going to do is I'm going to change my current connection. As you can see here, it's connected as Kurup. I'm going to change that to DB user. And once I change to DB user, what I'm going to do is I'm going to try and do select star from the table. Now, I don't have permission on all the other columns in the table. So you'll see as soon as I try to do select star, I get the error message saying that the ID column, the password column, the email ID, social security number, and credit card columns, permission was denied. However, at the same time, if I go ahead and just try to do select username, which is the only column on which I have permission, you'll see that I'm able to access the information. So this is one way that I try to avoid having to encrypt data, especially if I'm worried about external users accessing the information. Again, this doesn't really protect you from internal users like a bad DBA, etc. But having said that, as you can see here, this is what principle of least privileges is about. It allows you to go ahead and specifically grant not just access to a database, but inside a database, even a table, and inside a table, a specific column. Most of the time, what I see people doing is they just go ahead and do it this way, where they grant select permission on the entire table itself. And that's fine as long as you want to go ahead and just store the data as it is. But if there are some very sensitive columns, usually I like to go ahead and at least deny permission on the columns that I think that they shouldn't be watching. So that's that. But most of the time, this is not how people access the data in the database table. They create store procedures and they access it to the store procedure. So let's go ahead and do that right now. What I'm going to do is I'm going to create a store procedure here. And what the store procedure is going to do is it's going to access select star from the secure table. So what you'll see here is I already made sure that it's not supposed to be able to view the data in the table, and you saw how that error message showed up when we tried to do select star. I'll just go ahead and show it to you real quick again. So if I do select star from, you see I get the error message. So I'm going to revert back to the admin account so I can create the procedure. So I'm going to say create a store procedure, and this time again you'll see that what I'm doing is I'm making a store procedure, but inside the store procedure I'm still doing select star from secure table. And because it's a store procedure, I need to grant it execute permission. So I'm going to say grant execute on secure data blah 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 to the user DB user. So when I do this, what you'll see now is if I try to execute the store procedure as DB user, okay, I just have it right here, right? Notice what happens when I run the procedure. You can see that in spite of the fact that I have not explicitly given permission to the remaining columns, by giving execute permission on the procedure, it is implied that I have permission to do whatever the procedure expects to be doing. So in this case, the procedure expects to be doing select star from the secure table, and therefore in order to execute the procedure, I need to have the permissions to do select star as well. So you can see how you might take principle of least privileges to a very granular level by even granting column level permissions on the underlying table, but that can all be bypassed if you're not careful about how the execute permissions are being granted to store procedures. Now this is something that there's really no workaround for it. It's just about you making sure that you write code inside the store procedure properly and make sure that you're not displaying information unnecessarily. So having said that, here's what happens otherwise. Not necessarily that you always go ahead and fetch data only from tables that exist inside the database. Most of the time what happens is you can create a store procedure which is fetching data from an internal system table. So in that case, what happens is you can just go ahead and you can see I've written select star from sys.syslogins, which is a pretty important table from a security perspective of SQL Server. So as I've created that procedure, what you'll see is if I execute again as DB user, notice how I'm able to go ahead and execute logins, and you'll see that I'm not getting permission right now because I've not granted execute permission on get logins procedure. Correct. So you might want to go ahead and grant your DBA developer the permission to that particular procedure, and as soon as that's done, you'll see that when I execute it the second time around, I will have permission to now go ahead and query data. Just a second. Looks like I didn't grant that permission. Okay. All right, so I'm executing as DB user, and you can see that count 1. So the point I'm trying to make here is that a procedure by its very nature gets all the permission it needs to do its job, and that can mean access not just to the user created tables but even the system tables. And having access to that kind of information is pretty bad, because that allows the hacker to then get a better understanding of how you're coding, what are the loopholes in your system, and then exploit them. Now I can hear that maybe some of you are thinking that, well, nobody writes their code like this, nobody writes select star from syslogins, etc. in their code, right? But having said that, here's one thing that you might do. So for example, I've got a table that I'm going to create now, and I'm going to say create a table called my data and insert some data into the table called my data. And then I'm writing a procedure, as you can see here, which is using some kind of dynamic SQL. So you'll see that I've got a variable called @SQL, which is select star from blah 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 where condition, and in the where condition the application formulates the where condition and passes it in as a store procedure, as an input to the store procedure, right? And this is fairly common. I see it happen in a lot of places, especially where there are websites where the where condition changes frequently. For example, on job sites where you might have one where condition which is filtering by experience, another by salary. You might have it on retail websites where people are searching in terms of the number of bedrooms or the type of the property or the location of the property. You might see it in retail where people are searching it based on a category or the price or color, and the where condition is something that you can't always hard code. So the application basically formulates a where condition and passes it in this form. Now, the problem that you'll face with this kind of approach, as you can see here, is I'm just going to go ahead and grant execute permission to the DB user, and I'm going to show you what SQL injection looks like. So in this case, I'm going to go ahead and say that my DB user already has permission to execute this procedure called bat coding. But when the application is being executed in the where condition, in the text box, this is what I type in. So you'll see that when I execute this, it's going to go ahead and pass this value into the where condition. So what SQL Server is actually going to be executing will look something like this: select star from my data where. And this is the query that actually SQL Server is trying to execute when it reaches this step. So let me go ahead and just run this real quick and show it to you. So you can see how I had not granted select permission on the my data table, and therefore the error message shows up for my data. But immediately after that, I've said select star from syslogins, and syslogins is an internal table, and therefore I don't really need to specifically grant permission. That permission is implied by default, and therefore you can see I've got details over here about the syslogins, which actually helps me then further figure out how I want to access other usernames and try to figure out if there's a username that might contain possibly a weak password that I can exploit. You can notice here that the create date for the account is 2003, which is kind of weird, but that's just how it is. So as you can see in this video, what happens with the principle of least privileges is that by granting permissions individually layer by layer, you're restricting access to the underlying objects, which is a good thing. But at the same time, once you've done all of that, if you go ahead and write the code for your store procedures incorrectly or bad, as the way you've seen here, you might undo all that good work that you're doing in terms of securing or locking down your database. So this is what principle of least privileges is about. You want to make sure that you're granting the bare minimum permissions to the object layer, but that's only one half of the problem. The second half of the problem is making sure that once you've done that, you don't open up backdoors or channels the way that I've just shown you right now by writing a store procedure, which is basically doing a select star maybe and accessing columns that it's not supposed to be using, maybe dumping data into a temp table where it can be queried off. As you can see, you're using dynamic SQL, which is fairly common. So there are a number of ways that a procedure can end up bypassing a lot of the implementation that you're doing from a security standpoint. So there are two parts to it, and you need to be aware of both of them so that you can implement it properly. Now, the reason I'm focusing so much on principle of least privileges is because, like I mentioned in the first video, doing this right guarantees about 60 to 70% security against the most common, frequent type of attacks that the database encounters. So just a good strong password and bare minimum permissions is good enough to save you from a lot of casual attempts at trying to do data theft on your environment. And as a database professional, there are a few things that I expect everybody who attend interviews, etc., to know. And some of them is like indexing, which is kind of like expected that everybody knows what it is. And another thing that I look forward to when I interview people is their understanding of security principles, specifically in terms of principle of least privileges. And it's just something that you have to know. It's not really an option anymore, especially considering the kind of landscape that we have nowadays. So this was the first video, the second video in our series on securing the database. I hope you've enjoyed this video, and thank you for watching.